1, 2, 3, and 4, and then I think 5 can be done on decimals, so we'll end up doing them all. So 1 cannot be done on decimals, so you have to know the words and translate them correctly. The quotient of, so we're dividing the following things. 3 times a number squared, so those are going to be the things in your numerator. And 6 less than, so that turnaround phrase, so x minus 6. Questions on that? Two is just an evaluating problem. You can use your calculator or Desmos. Could have used Desmos for that. So if you put in the absolute value, put in everything, it would give you negative 18. If you were doing it by hand, after you put these in and combine them, you would get negative 9, but the absolute value signs would make it positive. And then when you multiply it, it would be negative again. So negative 18 was our answer. Three, you could have done by hand, but you could have also put it into Desmos. You would just have to count the slope and be careful. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. So down 6 to the right 12, so your slope would be negative 1/2. Or you could have used y2 minus y1. Questions on those three? Four cannot be done in Desmos. So this is something you would have to know. Range is your y values, lowest to highest. So what is the lowest value? It keeps going to negative infinity. What about the highest value? It also keeps going to the positive infinity. So I'm going to write this in both set notation and interval notation. Set notation is what we talked about at the beginning of the year. And then the interval notation, we talked about that when we were talking about inequalities. On the SOL, you won't see interval notation, but you will see set builder notation, so you will need to know what that looks like. And then 5, you had to graph. You could have used Desmos to double check what that looks like. So that would be a horizontal line at -3. So make sure you graph that. And have draw arrows. Questions on those? So next class, we're going to do 30, and you'll be turning in your check by answer sheet, so make sure you have all of those. And then let's go through the SOL standards. So I'll go through all of 6A, talk about the work, the answers, and then show you how to do those on Desmos, and then do the same thing for 6B. If you want to write down all the work, you're more than welcome to do that. If you want to just write down the answers, you're more than welcome to do that also. Just go back and rewatch these videos so you can see how to do it in Desmos and things like that. For number 1, parts A, B, and C, you were given different equations and had to find the slope. So if you were doing this by hand, you would subtract 3x, divide everything by 2, and your slope would be -3/2. For B, you just had to divide everything by 3, so your slope was 4/3. And then for C, you didn't really need to do this work. This is extra because it gave you the slope already, 2. For number 2 and number 3, you had to find the slope using the given points. 2 actually gave you the 2 points, and you use your y2 minus y1 over x2 minus x1. So the slope for number 2 was 1/2. For number 3, you had to know that the x-intercept of 4 would be written like this as an ordered pair, 4, 0. And you could use those 2 points, and you would get 1 for your slope. And then for number 4, this is kind of like the first couple where you have to solve. If you got rid of x by subtracting and divided, you would get a slope of -2. Questions on any of those? Five, you were given 2 points, find the slope between them, and that was -4. 6, you were given 2 points because you had to know how to write them as ordered pairs. X-intercept was 5, 0, y-intercept was 0, 3, and then you could use those to write your slope, which was -0. Yes. Yeah.
It should be.
Questions on those two? I'm going to show you those ones in Desmos, and then we'll go on to 6b. So for 1a, put in the equation, find 2 points that cross the grid lines exactly, count your slope. Same thing with 1b. 1c, you didn't necessarily have to do that because the 2 was given, that was your slope, but you could still do that and check it. For number 2, if you put in the 2 points given, you could use the graph to count your slope. So that 1/2. Same thing with 3, but you have to know what that second point is, and that slope was 1. Four, you had to find the slope, so find 2 points that cross the grid lines exactly. 5, you were given 2 points, so you could count your slope and simplify. And then 6, if you knew how to write the 2 ordered pairs, then you could put those in and count your slope. Questions on Desmos on any of those? For 7 and 8, you had to plot 2 points on the lines. You could have solved it, got your slope and y-intercept, and then used that. You could have used Desmos to plot the x and y-intercepts. So as long as you have 2 points that fall on the line, it doesn't matter what 2 points those are. Number 9, you were given a point and an x-intercept of 3, so you had to know that ordered pair was 3, 0. And then find your slope, either on the graph or algebraically. And you could do a couple different things. Use your point slope to find your y-intercept, or use your slope and one of the points to go up or down and find your y-intercept. Was the same, except this was given, you were given your y-intercept, so that was 0, -3. So after you found your slope on the graph or algebraically, your equation would be given and you could graph that line. (11) is very similar to 6. They have the same points. So if you knew that information already, you didn't have to redo this part to find the slope. It gave you the y-intercept, so this would be your equation. And then in 12, this is where it's a little different, because now they give you a point and they say write an equation that's parallel to the one that's given. So we have to remember a couple things. If it's parallel, they're going to have the same slope. So slope of 2. So you can use that slope and that point to find your new equation by using your point slope. But what happens to work out is these end up being the same line, so they're not actually parallel. And then I'll show the answers for the next few. For 13, because it's perpendicular, you have to remember that's a negative reciprocal slope. So we take this slope, we flip it, and if it was positive, we make it negative. And then you can do the same work with that new slope and your point. Use your point slope, find your equation. 14 was back to being parallel, so you had to solve this equation for y, get x away from it. Know that it's the same slope and do the same process. And then 15 was perpendicular, so you had to solve this for y, then change the slope, flip it, and make it positive because it was negative, and then do the same process. Now, if you don't remember the work, if you remember how to do it in Desmos, then you don't need to remember the work piece of it. I'm going to show you that in Desmos really quickly. If you need me to come back to this after lunch, I will do that. Okay, so starting with 7, this one was plot 2 points, so you could have looked at your x and y intercept or made it a table and looked for any points. Same thing with 8. I clicked the wrong one the first time. If you have your 2 points on here, and you write in your y equals mx plus b and hit sliders, you know what your y-intercept is, -3. And you can adjust the slope until it goes through that. I just can't get it exactly. The 0.8 was 4/5. It works. You just can't convert it. Okay. And then we'll talk about the remainders when we get back to it. Let's finish these and then we will move on. For 11, you have your 2 points, so you can graph those. This did not go to the sliders. That's weird. I don't know why I didn't use the sliders. Okay, anyway, that one was supposed to add the sliders, and then you could have changed it to the y-intercept and changed the slope. Let's see if the other one does that. That may have also been one. 12 is the one that was parallel. So if you put in the point, put in the equation, and then put in your y equals mx plus b, added in sliders. The slope has to be the same, so you could change that to 2. And it has to go through the point that was given, so if you move this, move your y-intercept until it goes through that point. They ended up being the same line, which shouldn't have happened, but it did in this case. $13 was perpendicular, so same thing, put in your point, put in your equation, type in your y equals mx plus b, add all your sliders, change your slope to the negative reciprocal, so 1/4, but make it negative. and then move your y-intercept until it goes through that point. And that would help you find your equation without doing all the work. Same thing for 14 and 15. This one's back to being perpendicular, but you don't have to solve this. You can just put it in. You would have to count the slope of this line, though, and know that it's 3. That way you can change this to 3. And then change your y-intercept so that it goes through that point. So this only goes up to 10 and negative 10. So if you saw what just happened, it got to negative 10 and it wasn't enough. So you would have to change it manually. And then 15 was your perpendicular. So again, count your slope of this line. And I think it was negative 5. Put in the opposite, the positive 1/5. And then change your y-intercept until it goes through that point. Anyway. So later you'll have some time to practice Desmos stuff as well. If you've not been trying these on Desmos, make sure you go back and try them on your own, in class, after school, before school, anything like that. That way you know how to access and use Desmos, because that'll be the only calculator you use on the SOL. The ones that are due next Thursday are A6c, that's just one question, and then A7a through D. So A7a, B, C, and D, and then A6c. And we're almost done with these. So do make sure you're going back and trying those. A6c and A7a through D. You'll notice that a lot of the A7 stuff is stuff we did at the beginning of the year, relations and functions, domain and range, stuff like that. Right. And then everyone should have these notes in front of them. If you have your laptop out, you can close it, because you won't need it for this. Okay. This is the last method of factoring. So as a review, we talked about a bunch. GCF, finding what they have in common, difference of squares, if you have perfect squares. Last class we talked about the basic trinomials when A equals 1, and how we multiply to get to the last, and add to be the middle. And then grouping, where we have 4 terms and we split the middle and do all those things. This is like a combination of some of that stuff, like the grouping, the GCF, the trinomials, kind of all 3 of those. So I'm going to walk through the process and then we'll do some examples. So in this, you'll be given some trinomial where you'll have an A value that is not 1. You're going to look and see, does it have a GCF? That's always going to be your first step. Then you're going to take the A value and the C value and multiply them together. After you multiply those two, you'll find whatever that is. Find factors of that number that add to be B. So kind of the same as last class, but not at the same time. After we find those numbers, we're going to take our 3 terms and rewrite them into 4 terms, splitting the middle. And then once we have our 4 terms, we're going to use grouping and find our answers. Okay. I'm going to color code this. If you would like to color code your own, feel free to do so. You may also need more space, so feel free to grab extra paper. So for example 1, does this have something in common that we could divide everything out of? Do they each have an x? Can you divide the 3 by 2? Is there something we can divide each one by? No, other than 1. Sometimes that happens. Sometimes you have a DCF, sometimes you don't. But looking for it first will help you practice when you actually have one. So the 1 wouldn't do anything, so we're not going to do anything with that. Then we're going to multiply 2 and 3. What would that give us? 6. So we're looking for 2 numbers that multiply to be 6, but add to be 5. What 2 numbers would work? 2 and 3. Positive 2, positive 3. So then we're going to rewrite our 3 terms into 4. The first and the last stay the same. So 2x squared. But instead of the 5x in the middle, we're going to write the 2 numbers we just found. The middle term had an x, so these will also have x's. So plus 2x plus 3x. Does not matter if you put 2x or 3x first. You'll get the same answer regardless. And then plus 3. So now we have 4 terms, so it's just like what we were doing last class, grouping. Split it down the middle. What do the first 2 have in common? 2 and x, yes. So if we're dividing everything by 2x, sorry, not everything, just these first 2 things, what would be left? We could say, is that off? X plus 1. Bring down your sign, the plus. What do the second 2 have in common? Positive 3. If we divide that out, what's left? X plus 1. Remember that the inside things should be the same. If they're not, something's wrong. And then you can use that to write your answers. Remember that the outside things go together, 2x plus 3. And if the insides are the same, which they should be, that is your other answer, x plus 1. What questions do we have on that process before we do some more? All right, let's try example 2. Does that one have a DCF? No. Other than 1. So it always has a DCF of 1 no matter what, but the 1 doesn't really help us. Okay, so then multiply 5 and 6. What would that be? 30. So 2 numbers that multiply to be 30, but add to be negative 17. And 2, if they're both negative, that would work. Okay. Then rewrite as 5m squared. As you start doing this more, if you see 15 and 5 go together, like I could divide them both by 5, you could put them together, but you don't have to. If you want to put 2 first, that's also fine. That shouldn't have been squared. Okay, so split those down the middle. What do those first 2 have in common? 5. 5 and m. And if we divide that out of the first two, what's left? What would 5m squared divided by 5m give us? Say that again. M minus 3. Right. What do the last two have in common? 2, but it's negative. So when you're dividing, divide by negative 2, your signs are going to change. What would be left? Minus 3. So then your final answers would be what? Look at the numbers on the outside. So I could write up minus 5 and minus 2 and then minus 3. Questions on that? Let's move on to example 3. Matthew, make sure you're writing this down. Does example 3 have a GCF? No, other than 1. But that doesn't really help us, so moving on. 6 times negative 4 would give us negative 24. So two numbers that multiply to be negative 24, but add or subtract to be negative 5. So one of your terms has to be negative. What would those two numbers be? Which one would be negative? So then rewrite it into 4 terms. 6y squared. Do we want the negative 8 or the 3 to go first? Okay. If you put the 3 first, that's fine. We will get the same thing at the end. And then what do the first two have in common? Y and 2. So if we divide those both by 2y, what would be left? Can we make sure you're writing this down? Y minus 4. What do the last two have in common? One is the only thing they have in common. So nothing else, you can always divide out a 1. So then the inside would be the same. What would those two factors be, the two answers? The inside pieces and the outside pieces. 2y plus 1 and 3y minus 4. Do we have any questions so far about any of this? Going on to example 4, same process. Does this have a GCF? This one again. Multiply 12 and negative 5. What would that give us? Negative 60, but yeah. minus. So find two numbers that multiply to be negative 60 but add to be 11. One of them will have to be negative. What two numbers work? Matthew? Mm-hmm. Which one will be negative?
4.
Yes. So rewrite those. 12c squared. Does not matter which one you put first, so let's say I do 4 first. Negative 4c plus 15c minus 5. Split it down the middle. What did the first two have in common? 4c. If we divide that out, what's left? Not squared to c. Minus the c's would cancel. Minus 1. What did the last two have in common? 5. Positive 5, so plus 5. And if you divide that out, what's left? C minus 1, 3c minus 1. So then our answers would be what? Nature. We're going to move on to some examples with GCF. We're going to do 1, 2 different ways, and then one more, and then one other thing that we have to talk about. So on the back of this, in this bottom section, we're going to start with number 10. So look and see, does this have a GCF, and if so, what is it? Can you divide 20 by 3?
Oh my god, I was the wrong one.
That's okay. But you're close. So you're close. 4. So if we divide each of these by 4, what's left? Later. Double check that one. What would that middle one be? Anyway. And then minus 6. And then the process is the same. We just have to keep bringing down that factor 4. So multiply 5 and negative 6. To get negative 30. And you're looking for two numbers that multiply to be negative 30, but add or subtract to be negative 13. What numbers would work there? Yeah. Negative 15, positive 2. So then we can rewrite 4 on the outside, 5n squared minus 15n plus 2n minus 6. And then split the middle and keep going. Bring down the 4. What did the first two have in common? 5n. We divide that out. What's left? What would 5n squared divided by 5n give us? N and then minus 3. What could we divide out of the last two? Positive 2. And what would be left if we did that? And minus 3. So then when we go to write our final answers, we would still have the 4 in front. And then the rest are the same, so 5n plus 2 and n minus 3. Right, we're going to do the same problem, but a different way. So write this problem underneath where you have space. And this would be, if you forget to check for the GCF, this would be what would happen. Right, so let's say I completely forget to do the GCF first and we multiply these two. What would that give us? Times negative 24. Now we're looking for factors of negative 480 that add or subtract to be 52. The numbers are really big. That should tell you that I probably could have taken out a GCF, but you can still do it this way. So if you're thinking of factors of 480, I don't know them off the top of my head except for they can be divided by 2 because even it ends in a 0. I would say look for the obvious things. It ends in a 0, so maybe 5 or 10 or 20 would work. Let's try the middle of those, 10. If I divided this by 10, that would be 10 and 48. Could I make one of those negative and add or subtract them together to get 52? Negative 52? No. So then from there, I can either go up or go down. So can 480 be divided by 9? What about 8? What would that be? 8 and what? Could we make one of those negative and add or subtract them together to get negative 52? Yes. So you may not have to list out all the numbers, but that might help you if you get bigger numbers. Which one would be negative? 60. So then we could rewrite this into 4 terms. 20n squared. I'm going to put 60 with 20. Negative 60n plus 8n minus 24. And then split the middle. What did the first first two have in common? 20n. What would be left if we divided that out? N squared divided by 20n. N minus 3. And then what could we divide out of these last two? 4 works, that's not the highest. 8. Positive 8. And then what would be left if we divided that out? Oh, minus 3. But then our factors would be 20n plus 8 and n minus 3. And the 20n plus 8 can be factored more. What could we divide out of both of these? 4. Leaving us with what on the inside? 5n plus 2, and then we would just bring the other one down. So you could do it this way, as long as you remember to keep factoring this at the end. That way you get that what would have been the GCF out. If you don't do this, you'll be missing a piece. But you'll also end up with bigger numbers. So keep that in mind as you move forward. Factoring out the GCF makes it smaller, makes it easier, nicer numbers to work with, but it can still be done this way. We're going to do 11 and then one other thing related and then something. Okay. Does 11 have a GCF, and if so, what is it? 5. If you divide everything by 5, what's left? What would be left here? We're dividing every single thing by 5. What's 10 divided by 5? 2. Say it louder. 75 divided by 5? 15k and 35 divided by 5. Okay, and then multiply 2 and 7. So you're looking for two numbers that multiply to be 14 but add to be 15. Closer those numbers are, one of your factors is going to be 1. So what two numbers will work? Say it louder. 14 and 1. So 2k squared plus 14k plus 1k. I forgot to do this. Plus 7. Split the middle. What do these first two have in common? 2 and k. You divide that out, what's left? K squared divided by 2k. K plus 7. What did the second two have in common? There's 1. then your factors would be 5 on the outside, 2k plus 1, and k plus 7. Do we have any questions on this process with GCF? Somewhere where you have space, I'm going to have you write down these questions. Write down these two for certain. These are the two we're going to do together. These two I would write down so you have practice. So x squared plus 2/3 x plus 1/9 and x squared minus 4/3 x plus 4/9 are the ones you need to write down. The other two I would write down so you have practice. And I'm going to show you 2 different ways on how to solve these, and you can pick and choose. So with the first one, it doesn't look nice because of all the fractions. So we could get rid of all the fractions by looking at the denominator of the c value, so 9, and multiplying everything by 9. So we have 9x squared, multiply 9 and 2/3, how many would you get? 6. And this would just become 1. So now it looks nicer. It looks like the questions we've been doing. Look for a GCF, but it's just 1. Multiply 9 and 1. And you're looking for 2 numbers that multiply to be 9 at D6. Yes. What were you going to say? 2 numbers that multiply to be 9 but add D6 would be what? 3 and 3. So when we rewrite this, we have 9x squared plus 3x plus 3x plus 1. And then we would split the middle and group them. So what would the first two have in common? 3x. Leaving us with what? X plus 1. What do the second two have in common? Positive 1. So it would stay the same. So then our answers would be 3x plus 1 and 3x plus 1, or 3x plus 1 squared. And all of these are going to have the same type of answers where they repeat twice. What questions do we have on that process before I show you one other way? So if that way makes sense, do that. If you are looking at them and can see it this way and want to do it this way, then you can also do it this way. So for this problem, if you're looking at this and can find the 2 numbers that would multiply to be 4/9 but add to be negative 4/3, so you would have to think about what times what would give you 4, what times what would give you 9, what would that be? What times what will give us 4? 2 times 2. What times what will give us 9? 3 times 3. You would also have to take into account the sign. So this is positive, so they either both have to be positive or both have to be negative. This is negative, so they would both be negative. this is technically the answer, but you won't ever see factors with fractions in it. It'll be rewritten. So you would have to know how to rewrite it. So I'm going to take the number, set it equal to x, and then I'm going to get rid of the 2/3 by combining it with the x, making this side 0. So first we're going to multiply both sides by 3, and then get rid of the 2 by subtracting. This would give us the same thing as this. So this is how you would write the factors. So if you can see the numbers without doing it the first way we did, and then be able to change them, then you can do it this way. If not, you'll have to do it the other way. Okay. Questions on this? And we don't have a lot of time left. I wanted you to practice some SOL stuff using Desmos. So if you still have your SOL testnav that I gave you a long time ago, take that out, and I want you to try numbers 1 through 7 using Desmos, so make sure you have Desmos out. If you need another one, come see me at that back table. I will give you another one.